Good evening, everyone. I hope you're all doing well. So, there's actually nobody on the session this evening. I'm not sure what happened there. Please remember that the sessions only don't take place if I do inform you that it's not taking place. Like, I will send out an email and say to you that we're not having a session this week because I'm giving you a bit of a break from all of the assignments being due, that kind of thing. But other than that, sessions will take place as normal every Wednesday evening at 6 p.m. So I am going to go ahead with the session and just record it for you guys so that you can catch up, obviously, at a later stage. And I'm going to be doing the section of your binomial and Poisson distributions. And this is learning unit 6. We've covered up until learning unit 5, up until this point, which is everything that was in your assignment 2. And the next section is learning unit 6. It is a section called probability distributions, but in particular, we look at your binomial and Poisson distributions. And I am going to be doing the questions on the screen that are circled. And if I do have time, I'll do the last one on the page as well. But I will just do the normal 1 hour session, and if it is possible, we'll do that additional one. But the plan is to work on the questions that are circled. So I'm not going to waste time. Let's get straight into it. And what the learning unit is about, just to reiterate, is the focus is on binomial and Poisson distributions. So I am going to upload other recordings, other videos on these two sections, which make up learning unit 6. But obviously that together with this and your slides will suffice for the learning unit. I do, once again, as I always do, advise to please make sure that you have gone through the slides before you listen in on the session. Or if you want to keep your slides open as you're listening in on the session, that's fine as well. So you can follow as we're going through the content. It isn't a bad section, but it is more statistical based. So I did mention when we were working with Learning Unit 5, when we started that section, I said to you that this is where we're starting to get into the statistical part of the module. So the first half of the module is from Learning Unit 1 up until Learning Unit 4. It's more mathematical based. And then the last couple of learning units, so Learning Unit 5, 6, 7, 8, and 9 are all mainly statistical based. So these are the sections where you're going to really get into the statistical part of it. We're going to look at a whole lot of statistical tables, different formulas, methods that I used. And this is one of the learning units where we do introduce sections that you have not come across before, or formulas and methods and a whole distribution that you've not come across before. So I do suggest again to please make sure you go through the slides, get an understanding, get a feel for what the learning unit is about, what you're looking at here. Remember, this is also one of the sections that are optional in the exam. So in terms of the exam, this is part of section C usually. So section C generally has learning unit 5 as one question, and then the other question is learning unit 6 and 7 combined. So this is where this learning unit comes in section C. So you do have the choice of either going with learning unit 5, which honestly I would advise because it is the easier of the 3 learning units, and it's also the introductory learning unit in terms of statistics and probabilities and so on. So I would suggest going with learning unit 5. You also have a fairly good knowledge of it because naturally it was tested in your assignment 2. But again, it's entirely up to you. If you do prefer learning unit 6 and 7, then that would be the question you'd go for under this section. So we're obviously still going to cover all of the content so that you are able to make a choice on your own. So let's go ahead with these questions. So in terms of a binomial and a Poisson distribution, I'm just going to draw up a little table sort of at the top here, which is explaining or identifying the main differences between the two. So a binomial distribution, firstly, is where you're going to look for the words so many out of so many. Or they would say to you, for instance, 20% of the time. So I'm also going to say a percentage could be given to you. Then, and I just want to highlight before I move on, I just want to highlight if you look at this that's underlined here in question 1.2 on the screen, it says 1 out of every 5. And then here it says 1 out of every 10. So this is where you are then looking at a binomial distribution because it says so many out of so many. Then the next one, a Poisson distribution, is where you're looking for the word average being mentioned to you. And again, I'll highlight for you in the question. So for instance, question 1 here says that it has an average of 4 customers. In number 2 here, it also says on average. So even number 1.2 at the bottom here also says on average. So as long as you see the word average, it immediately says to you that it is a Poisson distribution. Then in terms of the formula for a binomial distribution, the formula is NC x multiplied by p to the power of x multiplied by 1 minus p to the power of n minus x. So this is the formula that's going to be used for binomial distribution. I will explain to you when we are working with the example what is what in terms of the variables that go into the formula. Also, this formula is included in the formula sheet, so you don't have to worry about about learning this formula off by heart. Excuse me. So you don't have to worry about learning this formula. It is in the formula sheets. And then, as I said, when we go through the example, I'll show you what represents what in terms of the formula. So this is the formula. Sometimes in certain questions, you might only have to use it once. In other situations or questions, you might have to use it a couple of times and maybe add or subtract and that kind of thing. But again, when we look at some of the questions, I'll explain that. Then in terms of the Poisson distribution, here the formula is e to the power of minus a multiplied by a to the power of x over x factorial. So again here, this is in the formula sheet. You don't have to worry about learning it. And as we go through the questions, I will explain to you what is what. But in terms of, and this is something that I can't explain at this point, the average that they give to you in the question itself is the letter A in the formula. So that's something you can bear in mind when we get to the actual questions. And let's actually start to work with them now so that we can understand how to carry out these questions and these equations. So just a little bit of information at the top to help you distinguish between the two. It is important that you identify which one you're working with because it obviously is a specific words that I use and specific formulas that need to be applied, and you obviously need to be able to identify which to apply in which question. Okay, so let's start with the first question. So it says to you that it has been found from experience. Sorry, I just want to clear the screen. It has been found from experience that an average of 4 customers buy cigarettes from a particular cafe in any given 15-minute period. So immediately from the question here, I'm going to highlight the words an average. Also, I want to just point out to you that it isn't always highlighted in the way that, oh, sorry, not highlighted, underlined in the way that it has been in this question. So these are all questions, and it's the same with all of my revision worksheets that I go through in the collabs. They're all questions from past papers, whether it's an assignment that was previously done, or an exam that was previously written, or a test from the full-time space. It's all questions that have previously come from an IIE assessment. So they are excellent indicators of the type of questions that you can expect in your assessment as well. So obviously in your case, in particular in the exam, this is a typical question that you can find in your exam. So the problem when it comes to that is that naturally the examiners change year on year most of the time. So in one year, you would find a situation like this where the examiner has particularly underlined the word an average. And then even in the next question, they highlighted 1 out of every 5. Now, you cannot guarantee that this will always be the case. So it is important that you read very carefully when it comes to these questions, because if they're just giving you this whole paragraph of information and they haven't actually underlined or highlighted a particular word, then it's easy for you to just read through that without realizing that you read a word that was actually significant to the question. So please make sure that you do pay attention to these wordings, and that helps you identify which rule to follow. Like in this case, if an average wasn't underlined, then it's easy to just read that sentence as it has been found from experience that an average of 4 customers buy cigarettes from a particular cafe in any given 15-minute period. Whereas what we needed to focus on here was that they gave you the average of 4. So I'm just going to highlight the 4 part as well. And immediately, as I said, the moment they give you an average, it says to you that this is a binomial, oh, sorry, this is a Poisson distribution. So when it is a Poisson distribution, that always means that there's a letter A involved. Also, I'm just going to rewrite the formula. So the formula is e to the power of minus a multiplied by a to the power of x over x factorial. And whenever we are working out these equations, we always say that it's the probability of x is equal to, and then we have the formula. So whether it's a binomial or Poisson, the formula will always start off by saying the probability of x within brackets is equal to ... whichever formula is obviously applicable. So in this case, because we know it's a Poisson distribution, we know that the formula is the one written on the screen, and that tells you as well that you have been given an average. So they said to you that the average is 4. So I'm just going to write on the screen that A is equal to 4, and now we can read the rest of the question. So the question says, what is the probability that more than 2 customers, and I'm going to read the question first as normal, and then I'm going to reread the question, because then the second time around, I'm going to point out important bits of information here and there. So it says, what is the probability that more than 2 customers will buy cigarettes from the cafe in any randomly selected 15-minute period, and interpret your answer. So firstly, we know that we're interpreting at the end of it. Without a doubt, there is always a mark allocated to an interpretation when it comes to binomial and Poisson distributions. Secondly, it says to you, what is the probability? So firstly, we know we're calculating a probability. Secondly, it says the probability that more than 2 customers will buy the cigarette in that randomly selected 15-minute period. Now, our focus is exactly the part that I had last underlined, more than 2. Now, why it's important is because I was pointing out earlier, sometimes you might need to do the formula more than one time, because sometimes, depending on the wording in the question, you can't just write out the formula one time and just use that answer as your final answer. depending on the wording, sometimes you might need to do it multiple times and add. Sometimes you might need to do it multiple times and subtract, and so on. There's different rulings under different circumstances and questions. So you do need to specifically look at what the question is asking you. So in this case, it's saying more than two. Now, with a Poisson distribution, and this is also something that's an important difference between a binomial and a Poisson distribution. So you can maybe also take this down in that little table if you have drawn up the table that I had at the beginning as well. With a binomial distribution, there is a sample size. So that means there is the letter n. So remember, n is always representing your sample size. Now, this is something that is always representing your sample size. Now, this is something that was also brought up in Learning Unit 5. You had learned there that n is referring to your sample size or the total value of your sample or the total number of people or data values that make up your sample. That is the binomial distribution where there is a sample size. And I want to point out an example of that to you. Like, let's look at number 2 here, where it says 1 out of every 5. Now, that immediately says to you that they've given you a value for, so 1 out of every 5 here. And then if you look at the question, it says, if we randomly select a sample of 8 new students, what is the probability that less than 3 will pay their fees in 10 monthly installments? So they've given you a sample of 8 new students. So that tells you there is a sample size, which is n is equal to 8 in this case. Now, the difference between that and a Poisson distribution, and I'm just going to take off this at the bottom here so you don't get confused while we're now working with the Poisson. With a Poisson distribution, there is no n value, so there's no sample size. Meaning there's no n. Okay, so there's no n in a Poisson distribution, meaning that it basically continues into infinity. So now they're saying, what is the probability that more than 2 customers will buy cigarettes from the cafe in that randomly selected 15-minute period? So I'm going to say here, continue into infinity. Excuse me. So if they're saying more than 2, that means that you're starting at 2, then you're going 3 because it's saying more than 2. So, well, no, you're actually not starting at 2 itself. It's saying more than 2. So it's starting at 3, 4, 5, 6, 7, 8, 9, 10, 11, and you're going to continue like that. So I'm just going to put an arrow here. And because there's no n, because there's no sample size, as we said, it continues into infinity. So basically you're starting at 3 and you're continuing into infinity. Now, why is that a problem? It's a problem because by saying more than 2, that means we need to write out this Poisson distribution formula every time we substitute a value after 2. So basically, we need to do this formula and substitute 3 into the formula. We need to do it again, substitute 4, then again, substitute 5, then again, 6, then 7, then 8, then 9, then 10, and then basically continue into infinity. Now, obviously, that's not possible. Where do we stop? How long do we go on for? We obviously naturally cannot continue into infinity. So we need to know what can we do. If it's not possible for us to look at every other number greater than 2, which they said more than 2, if we look at every number more than 2, what do we do? Because we obviously cannot continue into infinity. Now, this is where the complementary rule comes in. So remember we learned about the complementary rule in the previous session under Learning Unit 5. We said that the complementary rule says, for example, I'll just write out the normal formula first, and then I'll explain with another example. So it says that the complementary rule says that the probability of A not occurring is calculated as 1 minus the probability that it will occur. So, for example, if we are saying the probability that it will rain today is 25%, and we had to ask what is the probability that it will not rain today. Remember, that's the word rain with the line on top. It indicates not rain. So the probability that it will not rain is always 1 minus the opposite, and the opposite of it not raining is the probability that it will rain. So it's basically 1 minus 0.25, which is the probability that it will rain. So the probability of it not raining is 0.75, which is 75%. So basically here what happens is we do the same thing. Whenever we find that we cannot calculate the 1 because it's too much or it's too many calculations to do, we then say 1 minus the opposite. So the same applies to this question now. Basically what we're going to do is we're going to say that if we are being asked the question of what is the probability that more than 2 customers will buy cigarettes in that 15-minute period, you're saying that the probability of X, remember that's always how we start writing out the question. So the probability of X being greater than 2, meaning more than 2, is then calculated as 1 minus the opposite. So the opposite of greater than 2 is less than 2. But because here, and this will always be the case, because on the left-hand side you said greater than 2, you didn't include 2 itself. You said greater than 2, meaning starting from 3 onwards. Then on the right-hand side, you have to include it here. So this is why we say it's actually 1 minus the probability of X being less than or equal to 2. So now you've accounted for the 2 here, but you didn't include the 2 here because here you started with everything above 2, which was the number 3 onwards. So now you have your formula. You know what you're working towards. You understand then that since it's continuing into infinity and it's unrealistic to do that many calculations, we say that the probability of X being more than 2 or greater than 2 will now be 1 minus the opposite, which is the probability of X being less than or equal to 2. Now we can start to work with the question. So what will happen is we leave this as is, 1 minus, and now we look at what do we mean by X is less than or equal to 2. So we need to look at all of the numbers less than and equal to the number 2. So naturally, it's the number 2 itself because it's equal to 2. And then everything below that, less than and equal to. So equal to, we've got the 2. And then less than is the number 1. And you must always include the number 0 as part of your calculations. So basically what this then tells us is we need to do that Poisson distribution formula. Remember it had been written here, e to the power of minus a times a to the power of x over x factorial. We need to do that 3 times each time x factorial. We need to do that 3 times each time substituting a different value in place of x. So the first time we make x equal to 2, We calculate that value. The next one, we make x equal to 1. We calculate that value, and then we make x equal to 0, and we calculate that value. We then add them up, and it gives you this whole part here, which is the probability of x being less than or equal to 2. And then for your final answer, you say 1 minus that, and that will give you the probability of more than 2 customers buying cigarettes in that 15-minute period. Okay, so let's get started with that calculation. So we're going to write out the probability of x being equal to 2, the probability of x being equal to 1, and the probability of x being equal to 0. And now let's start with the first one. So the formula is e to the power of minus a. Remember, we said here that a is equal to 4. They gave you that information. So it's to the power of minus 4 multiplied by a again, 4 to the power of x. And then remember here, the first time x is equal to 2. So it's to the power of 2 over 2 factorial. Then the next one is the probability that x is equal to 1. So here it's more or less the same as the first one. The only difference is the x value is changing. So the average a stays the same. It's still 4. So it's e to the power of minus 4 times 4 to the power of 1 over 1 factorial. And then the last one, x is equal to 0. So it will be e to the power of minus 4 times 4 to the power of 0 over 0 factorial. And now you can calculate those values. So on your calculators, let me tell you where you can locate the respective values. So firstly, to make it a fraction, and I'm just going to show it to you on the bottom of the screen. On your calculators, on the left-hand side, just below the shift button, you should see something that says calculate, and this is on the top left-hand corner. So it says shift here, not the button below it, the one below that. So there's another button here, and then the one below that, it has something that looks like a fraction sign. It has basically two squares that are on top of each other, separated by a divide sign. You'll press that. So this is the one you press first. Then for the E value on your calculator, this is now on the right-hand side of the calculator. At the top corner, you will see that the first column from the right-hand side, it is the third button in that column. So it is literally like in line with this one, but on this side. So in line with that fraction sign, but on the right-hand side, it says ln, but above it, it says E, and it has a block. So this is for your Casio calculators. They're your normal scientific calculator. So you'll press shift. So this shift button here on the top left-hand corner, and then you'll press this ln button here, and it will give you the e to the power that you see in the numerator of the Poisson formula. So it's going to give you this. So remember, you first press the one that I had put the star next to at the bottom here. So this is step 1, press that. Step 2 is to press shift and this ln sign to give you the e to the power of. And then you'll put in, so it'll give you the E automatically. So let's try it out with the first one. So here at the top, it will be to the power of minus 4. And then remember, this dot in the center indicates that it is multiplication. So you will put in the multiplication sign. I would suggest you do that. put in the multiplication sign once you have put in to the power of -4. So basically, as I said, step 1 is to press the fraction button. Step 2 is to press shift and the learn button. Step 3 is the learn button. When you press E to the power of, in the power, you'll put in -4. That's step 3. Step 4 itself is then to use the arrow and put in the multiplication sign. Please remember, after you put in the number 4, it's still going to be at the top here, meaning with number 2, if you look at the bottom of the screen, it's still basically going to be here at this point where you are at the top, you're at the power. So this is why I say to you, you'll need to use the right arrow and come back down to the fraction, the normal base, not the power. And then you'll press the multiply button and you are multiplying by A, which is 4. So you'll basically type in number 4 again. Then you're going to press the button on your calculator. So I'm not sure exactly what your calculators say, but if you look at 1, 2, 3, basically. So 3 values after this one. So I'm going to highlight here. 3 values after the fraction sign. In that same row, it has a function that has a small rectangle and then it has to the power. I'm sure you know how to enter power on your calculator. So you'll press that and it will give you an option to make it a power. So your power for the first one is 2. So you'll press 2. So this is step number 6. You'll press 2 and then you'll go to the bottom. So navigate to the bottom of your calculator. Oh, sorry, the bottom of your fraction. So I'm going to say go to denominator. Once you're in your denominator, you will press 2 and then the shift button. And remember, I showed you already or explained to you already where the factorial sign can be found. It is literally below the mode button. So you press 2, shift, and below the mode button, which has a block and it has a negative power, this will give you the factorial sign. And then your will give you your answer. So your answer here would be 0.1465. You can leave these as 2 decimal places. Please make sure to follow instructions for this. I am specifically telling you here that you will leave these as 4 decimals unless your exam actually states to you that it needs to be. Unless your exam actually states to you that it needs to be in 2 decimals for this specific question. Okay, then the next one, and you can actually just use your arrows and your delete function to like remove figures here. You don't have to really go and type up the equation again from scratch. The advantage is that most of it is remaining the same. It's only the x values in the calculation that are changing. So it would actually just be, you can use your arrow, go back to the calculation, remove wherever you had the 2, which is just in the second part of the numerator, and then also in the denominator, you will change that. So here it will be e to the power of -4 times 4 to the power of 1 over 1 factorial. And this would give you 0.07 0.33. And then again, you'll then just navigate back to the formula using your arrows, and you'll just take out wherever you had 1, you will make it 0. So it will be e to the power of minus 4 times 4 to the power of 0, and then over 0 factorial. And this would give you 0.0183. Now that you have that, remember I said to you, you're going to add it up. And once you have added it up, you're going to basically say that it's 1 minus this answer. So here it is, excuse me. So here, when you add these up, and I'm just going to erase a bit here. It's 0.2381. So now all you're going to say is it's 1 minus the 0.2381, and your final answer here is 0.7619. But you need to obviously convert this to a percentage, so it's 71.69%. And then remember, you need to always interpret. So it says to you, and again here, and I think I did say this in one of the previous sessions in terms of interpreting, literally just look at the question itself and put in your final answer into that question and let it read as a closing statement. So for example here, and I'm just going to erase the screen and write down the final answer again so I can show you that. So here you're going to say, so 71.69%. So all you're going to do is, here's the question. Okay, it said, what is the probability that more than 2 customers will buy cigarettes from the cafe in a randomly selected 15-minute period? You're going to take your answer and put it into that and let it read as a closing statement. So you're going to say, there is a 71.69% probability that more than 2 customers will buy cigarettes from the cafe in any randomly selected 15-minute period. And that is how you'd interpret. So if you feel like it is confusing in terms of how to interpret, please follow this method because it's the easiest way to ensure that your interpretation is correct. You are literally just taking your answer and putting it into a statement format of how the question actually was. So basically, you're answering the question with this closing statement. Okay, so that is question 1.1 done. And this is an example of a Poisson distribution. Let's look at question 1.2. So it says, experience has shown that 1 out of every 5 new students, I'm just going to clear that screen. So 1 out of every 5 new students who enroll at a private educational institute agree to pay their fees in 10 monthly installments. If we randomly select a sample of 8 new students, what's the probability that less than 3 will agree to pay their fees in 10 monthly installments? And interpret your answer. So immediately here, 1 out of every 5 says to you that you're working with a binomial distribution. And I was pointing out earlier that 1 out of 5 tells you that it's 1 over 5, and 1 over 5 needs to be converted into a decimal. So on your calculators, when you put in 1 over 5 and you convert that to a decimal, it will give you 0.2. But that is exactly what we need because, sorry, not 0.2. No, sorry, it is 0.2. So 0.2, please make sure to make it a decimal. Do not leave it as the fraction as is. Don't make it a percentage of 20% and so on. It must just be a 2 decimal place figure. It'll always be a 2 decimal place figure. That's how most of these work. They don't generally leave them as 3 decimals. Okay, so this is 0.2. That is your They said experience has shown that 1 out of every 5 new students who enroll at the private educational institute agree to pay their fees in 10 monthly installments. So here, that value of zero point 0.2 that we calculated, this is the letter P in the formula, and I'm going to write down the formula again just below this. So the formula for binomial distribution is NCX multiplied by P to the power of X multiplied by 1 minus P to the power of N minus X. So basically you have the letter P, which is here and here in the formula. Let's look at the rest of the information. So they said that they are looking at 1 out of every 5 new students who enroll at a private institution assessment. If we randomly select a sample of 8 new students, so immediately this says to you, and I had said it earlier as well, that n is equal to 8. So with a sample of 8 students, what is the probability that less than 3? So again, please pay attention very carefully to the wording of these questions. So it says to you that they are looking at less than 3. So now you're going to ask yourself the question, if we're saying less than 3, and I'm going to do this at the top. Okay, so I've written it out, the probability of x being less than 3. And here we're going to look at what does that mean. So less than 3, which numbers are we actually talking about here? So firstly, it's not including 3 because they're saying it's everything below 3. Secondly, below 3 refers to the numbers 2, sorry, I'm just getting stuck here. I don't know why it's not writing. Oh, gosh. Okay, so less than 3 refers to the numbers 2, 1, and 0. So here we are going to do the formula again that we see written up here, the binomial formula. Each time substituting a different value for the letter of x. Remember I said to you that once you know what numbers are going into the formula, you obviously then need to remember that it does include the number 0, and you also need to be able to identify, am I adding? Am I subtracting? Is there a specific rule that needs to be used? So here it is basically saying that you need to do the formula 3 times, each time substituting a value for x and then just add them up. So here, the first time around, you're doing the probability of x being equal to 2. Then you're doing the probability of x being equal to 1. And the probability of x being equal to 0. So again here, let's write it out first and then we'll calculate it, and I'll show you how to or what to press on your calculators. So here n we had already determined was 8. We had determined it on the left hand side here. Oh gosh, sorry. I had erased it in error instead of highlighting. Okay, so we had determined that n is 8, so you're going to say 8, and then it says c, and I'm literally following the formula. So ncx. The letter c leave as is. You're never going to change that. You're never going to put in a value for c. So it's 8c, and then now x is 2, so it will be 2 multiplied by, the next part is P, and we had already identified here that P is 0.2. So times 0.2. Sorry, my pen is acting up. I'm not sure what's wrong. So 0.2 to the power of x, so the x value is 2, and then it's multiplied by, there we go, and then it's multiplied by 1 minus p, so that's 1 minus the 0.2, 0 to the power of, okay, I don't have space here, minus the 0.2, 0 to the power of, okay, I don't have space here, so what I'm going to do is rewrite that whole thing at the bottom where I do have some space. Okay, so we're doing the probability of x being equal to 2, the probability of x being equal to 1, the probability of x being equal to 0. So the first one we said was 8C0. That would be 8C1. This would be 8C2. Then you're going to then you're going to multiply that by p to the power of x. So we said p is 0.2, x is 1, x is 2 here, then it's 0.2 to the power of 1 here, and then 0.2 to the power of 0 here. And then again, you're multiplying by 1 minus p, so 1 minus 0.2 to the power of n, which is 8, minus x, which is 2 here, 1 minus 0.2 to the power of 8 minus 1, and then 1 minus 0.2 to the power of 8 minus 0. And when you put these into your calculator, so let me show you how to put that onto your calculator. Literally pretty much as you see it, wherever you see the dot, it indicates its multiplication. So on your calculators, you'll type in the number 8. Then remember, and again, this is something I explained in the previous lecture, above the divide sign on your calculator, you will see the letters NCR. So the C is what you're looking for. So you're going to press 8 and then shift and the divide button. So 8, then shift the divide button, and then 0. I would suggest, honestly, the best way to do this is use brackets. So that first part must be in brackets. So maybe you can press the on sign again, then open bracket, 8, shift divide button, 0, and then, oh, sorry, I just realized that I did them in reverse here. This was supposed to be 210. I did it in the order of 0, 1, 2. So x is 2 here, so the x that you put into the formula must be the same value of x. Okay, so once again, as I was saying, in terms of entering it onto the calculators, so once you've done that first bracket, as you can see, there's a divide sign, there's a multiplication sign, there's a dot, so you'll press the multiplication sign. Use your brackets again. So open bracket, then 0.2, and then you'll press to the power of 2, and then again multiply, and then it's 1 minus the 0.2, and then to the power it will be 8 minus 2. So here your answers for the first one is 0.2936. The next one is 0.3355. And the last one is 0.1678. Okay, and now you just have to add them. So if you add all three, it is 0.7969. And that, as a percentage, is 79.69%. I'll write that at the top here. So now to answer the question, remember again, you just need to plug in your answer into that question and let it read as a closing statement. So they said to you, what is the probability? Let me underline and then I'll highlight when I'm doing the statement. What is the probability that less than 3 will agree to pay their fees in 10 monthly installments? You will say there is a 79.69% probability that less than 3 will agree to pay their fee in 10 monthly installments. And that's it for question 1.2. Okay, so that's the binomial distribution. Let's look at the other two. So the next one says to you, it has been found that on average, 5 cars use a service station in any given 15-minute period. So immediately here, the average tells you it's a Poisson distribution, and they've given you the average, which is 5. Again, there's no n. So I'm going to just write down on the side here that there's no n, meaning you are continuing into infinity. So then they say to you, for any randomly selected 15-minute period, what is the probability that, and the first question says, so there's actually two questions here. So the first question says, what is the probability that no more than 2 cars will use the service station? And interpret your answer. That's for 6 marks. And then they say more than 2 cars will use the service station. So now let's look at just the first one. So back to the first one, it says no more than 2 cars will use the service station. Now, what does no more than 2 mean? So if you look at the wording of this, no more than 2 means that 2 is your maximum. So we are actually saying it's the probability of x being, if 2 is the maximum, it's basically everything under 2. Inclusive of 2, because it's no more than 2. So 2 is your maximum and it's everything below that. So it's x being less than or equal to 2. So the equal to 2. So this is what we're actually looking at calculating. And if we're saying x is less than and equal to 2, then we need to know which numbers those are. So less than and equal to 2 means that it is the numbers 2, because it's equal to 2, and everything less than it, which is 1 and 0. So basically here, there's only actually 3 calculations that you need to do and then add them up. So technically what we're actually saying here, and I'm going to write it here, is that you need to make x equal to 2. So the probability of x being equal to 2 plus the probability of x being equal to 1 plus the probability of x being equal to 0. So now we're going to have, and remember this is the Poisson distribution. So the formula is e to the power of minus a times a to the power of x over x factorial. So let's write out that formula. So I'm just going to do it somewhere here. The probability of x being equal to 2, probability of x being equal to 1, and let's do the 0 here, probability of x being equal to 0. So exactly the same formula, but the only thing that changes each time is the value of x. So here it'll be e to the power of a is 5, so it'll be e to the power of minus 5 times 5 to the power of 2 over 2 factorial. The next one will be e to the power of minus 5 times 5 to the power of 1 over 1 factorial. And this will be e to the power of minus 5 times 5 to the power of 0 over 0 factorial. Okay, so here the first one is 0.0842. The next one is 0.0337. And the last one is 0.0067. And now you just need to add those. So when you add them, it's 0.1246, which as a percentage is 12.46%. So now to interpret your answer, so you're going to say there is a 12.46% probability that, and I'm just going to highlight here, probability that no more than 2 cars will use the service station. And that's your answer. Then for the next one, it says, what is the probability that, and I'm just going to highlight this in a different color so that you can see the question here. It says, what is the probability that more than 2 cars will use the service station? So now you're saying the opposite. You're saying the probability of X being greater than 2. Now again here, because there's no N value, that means if you're saying more than 2, you're starting at the next number, which is 3, and then you're going 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 into infinity. Again, it's unrealistic, so you're not going to go that route. Instead, you're going to go the route of the complementary rule. So the moment there's too many calculations to do, and generally we use a benchmark of 5, basically saying if it's more than 5 calculations that you have to do, or substitutions, or 5 times that you need to substitute, or more than 5 times, sorry, that you need to substitute into the equations, then immediately you need to use a complementary rule. Because this is how the rule works. When it's too many calculations to do, immediately the complementary rule comes into play. So here, since it's too many calculations to do, it's basically into infinity, we then need to use a complementary rule, which would say that the probability of X being greater than 2 is 1 minus the opposite, which is the probability of X being less than, and including 2 because it didn't include 2 on the left-hand side here. So here we're going to look at, and you're allowed to do this. So in a typical assessment situation, if you find, like in this previous question, when we did 2.2.1 here, we did already do the probability of X is less than and equal to 2, which is the same thing that we're subtracting here. You are allowed to just take the final answer, which was the 0.1246, and just use in this question instead of having to do the whole thing again, because you technically already did that part that's within brackets here that I highlighted. You did this already in the previous question. So you did it here, meaning you don't need to do the whole thing again. You are allowed to just pull that answer through. So it'll be 1 minus the 0.1246. And that would give you an answer of 0.8754, which is 87.54%. So to answer the question now, you would then say that, and again, remember, just take your answer and put it into that question and let it read as a closing statement. So you will say that, therefore, there's an 87.54% probability that more than 2 cars will use the service station. Okay, so that's question 2.2, and then the last one that we're working with, station. Okay, so that's question 2.2, and then the last one that we're working with for today, question 1.1 here, says that it has been found that 1 out of every 10 invoices, sorry. Yes, sure, not a problem, Kevin. That's perfectly fine. You'll be completely lost if you do stay on the session, so it's perfectly fine to do that. You as well, thank you. So it says it has been found that 1 out of every 10 invoices that are issued by Reliability Limited is incorrect. So 1 out of every 10 immediately says to us that it is a binomial distribution. So I'm going to write that down as well, that it's 1 over 10, and this is, remember, always the value of p. So as a decimal, and remember you must convert it to a decimal, it's 0.1. So then it says to you, if we randomly select a sample of 12 invoices. So immediately here, we know there's a sample size. They said it's a sample of 12. What is the probability? And here's the question. What is the probability that no more than 2 of the invoices will be incorrect? So no more than 2 means that 2 is your maximum. So it's basically saying that it's everything less than and inclusive of the number 2, which is 2, 1, and 0. So this means we need to work out the probability of x being equal to 2 plus the probability of x being equal to 1 plus the probability of x being equal to 0. And that would be our final answer. So we're going to do this formula 3 times, making x a different value each time. Okay, so remember the binomial distribution formula is NC x multiplied by p to the power of x multiplied by 1 minus p to the power of n minus x. So here n is 12, so let's put in 12 for all of them. C will be the same. X is 2 the first time, 1 the second time, 0 the next. Then it's 1 minus p, which is 0.1, 1 minus p, 1 minus p, and then it's to the power of x, so 2, 1, and 0. And then it is, sorry, I wrote the wrong thing first. It's actually p first, and then 1 minus p. So it's p, it's 1. To the power of x, that's 2. Then here x is 1, and here x is 0. And then it's 1 minus p, 1 minus p, 1 minus p, to the power of n, 12 minus x, 12 minus 2, 12 minus 1, 12 minus 0. Okay, so this is 0.2301, 0.3766, and 0.2824. Add those up and it's 0.8891, which is 88.91%. So now to answer the question, so that's 88.91%. So you'll say there is therefore an 88.91% probability that no more than 2 of the invoices will be incorrect. Okay, so I am going to stop here for today. The rest of the examples are more or less the same. It's just that obviously there's different numbers involved, but the idea of it stays the same. You will always look for keywords in these situations. So if it's a binomial distribution, you're looking for either a percentage, or they'll say to you so many out of so many, and then the formula is the one at the top of the screen. If they say, and remember there is an n value, then if they say the word average, you know that it is a Poisson distribution. The formula is e to the power of minus a times a to the power of x over x factorial. There's no sample size here, so this is continuing into infinity. So if they ever say more than a particular number, this indicates that you would need to use the complementary rule. And look for the key values that they're asking you to calculate. So, like more than 2 means that, and this is specific to a Poisson distribution. If they're saying more than 2, then it actually means that it's 1 minus the probability of x being less than and equal to 2, for instance. So please make sure to go through the content of the slides first, get familiar with these values, these interpretations, these little things that help you to identify the difference between the two. There are additional examples in the slides that can help you. And then obviously the ones we went through today, I will also upload additional videos for this learning unit. And then whichever questions I did not go through today. So the one on this page, the last one at the bottom here, I didn't go through this one here. Let me just highlight it. So I didn't go through question. Let me clear this and then highlight. Question 1.2 here at the bottom. I didn't go through this. Also didn't go through all of these on the next page. Please, can I ask that you try these out on your own? You try them, listen to the recordings, and try out the stuff in the slides first, and then come back and try out these ones. And I'll also make the solutions available to you in about a week's time so that you can practice for yourselves. And if you have any questions, please do let me know, but please do try these out as well, especially if you plan on choosing the section as one that you'll answer in your exam. Okay, so that's it from me. Enjoy the rest of your evening and your week, and I will chat to you again soon.